Okay, so we just covered the norm.dist function. Time to go over norm.s.dist, which is actually very similar. Now the norm.s.dist function returns the cumulative probability or the probability density at z from the z distribution, otherwise known as the standard normal distribution. And if we look at the arguments, you'll see that we have z instead of x, which is the z-score to calculate the probability for. And we don't have the mean and standard deviation arguments here, since the z distribution always has a mean of 0 and a standard deviation of 1. So we're just left with the same cumulative argument, in which true returns the area under the curve and false returns the height of the curve. So a possible question here would be something like, what's the probability of an Olympic basketball player being at least 1.5 standard deviations shorter than the mean? Alright, so we've got the standard normal distribution and want to calculate the probability of getting a z-score less than or equal to negative 1.5. So we want this area right here, which makes the function pretty easy. We just write norm.s.dist, we add the negative 1.5 for the z-score, and the true returns the area under the curve, which in this case gives us a probability of 0.066 or 6.6%. And if we had done false instead, then we get 0.13, which is just the height of the curve. Again, not the probability. So very similar process. Granted, these sorts of questions are less common and less intuitive than the ones that we saw in the previous lecture, but it is important that we start getting used to this function and calculating probabilities based on z-scores, since it's going to come in very handy when we're doing hypothesis tests. So let's quickly head over to Excel and go over an example. Alright, here in Excel, I'm going to go through the link on calculating probabilities with norm.s.dist, and let's see what we need to do here. What is the probability of a graduate getting a final grade 1 standard deviation away from the mean at the most? Alright, so that means that we need to calculate the probability of getting a z-score between negative 1 and 1, which means 1 standard deviation away from the mean. So the lower value is going to be negative 1, the upper value is going to be 1, and remember that in these cases where we want to calculate the probability between two values, we need to calculate the cumulative probability for the higher value first, and then subtract the cumulative probability from the lower value. So let's write our norm.s.dist function. The z upper is going to be this one, so 1. And we want to return true because we want the area under the curve. And then we just subtract, again, norm.s.dist, z lower, true, press enter, and we get a probability of 68.27%. And this may start ringing a bell. It might look a little bit familiar, or at least it should, because it's the same exact percentage from the empirical rule, which outlines that around 68% of the values live 1 standard deviation away from the mean. This is where that comes from. Pretty cool, right?